Good morning, children. Children, yesterday you have learnt about how to read log and antilog table, is it not? Today let me solve some of the numerical involving log and antilog value. The first one is calculate the equilibrium constant for the reaction at 298 Kelvin. The reaction is Cu plus 2Ag plus giving rise to Cu2 plus 2Ag. Given standard reduction potential of silver ion is equal to 0.80 volt and standard reduction potential of Cu2 plus is equal to 0.34 volts. Let me solve this numerical, children. Children, you know the expression which is used to find out the equilibrium constant that you already learned in the previous classes. What is that? E naught cell is equal to minus 0.0591 upon n into log of Kc. You are supposed to find out Kc, is it not? Now log Kc is equal to minus n into E naught cell upon 0.0591. Children, before proceeding for finding the Kc value, you should know the value of E naught and n, is it not? And those two values you can get it from the chemical reaction. Children, let us find out in this chemical reaction which one is undergoing oxidation and which one is undergoing a reduction. Look at here. In this, copper from zero oxidation state is getting converted into Cu2 plus. That means increase in oxidation number refers to what? Oxidation. So copper is undergoing oxidation, whereas +1 oxidation state of silver is getting converted to 0 in metallic silver. That means there is a decrease in oxidation number, which is nothing but reduction. Children, you know that oxidation takes place at anode and reduction takes place at cathode, is it not? Now let me write anodic as well as cathodic reaction. Look at here. At anode, copper loses 2 electrons to form Cu2 plus ions. At cathode, Ag plus ions takes up the electron lost by the copper to reduce Ag. Is it not? Now, I can write the cell representation. Now, look at here. Cu bar, Cu2 plus, double bar, Ag plus, bar Ag. Now you know that A, B, C. A stands for what? Anode. C stands for what? Cathode. What is B here? Shortridge. Children, you know the expression to find out the E naught cell, is it not? What is that? E naught cell is equal to E naught cathode minus E naught anode. Now what is E naught cathode, children? E naught cathode is nothing but Ag plus getting converted into Ag, is it not? A value is given. How much? It is 0.80 volts. Minus, what is E naught anode? This is Cu2 plus bar Cu, is it not? Now what is the value here? It is 0.34. Children, if you subtract, you are going to get 0.46 volts. So this is what? E naught cell value. Children, one more value you are supposed to find out, that is n value. Look at here, n is equal to how much? Children, 2 electrons are used by the reduction of 2Ag plus 2Ag. That means n is equal to number of moles of electron, that is equal to 2 moles of electron, and the value of n is equal to 2. Let me substitute the value here. Minus 2 into E naught cell is how much here? 0.46. 0.46 upon 0.0591. Children, if you multiply, you are going to 0.92 upon 0.0591. You just neglect the sign here, negative sign. Okay. Now, this is what? Log Kc. If you simplify, log Kc is equal to 15.56. Now, how do you find out the Kc value? Kc value can be found out by taking anti-log of 15.56. Is it not? Now, if you find out the anti-log by using the anti-log table and you know how to find out, you are going to get, look at here, 3.361 into 10 to the power of 15. So, this is what? Kc value. Children, always remember, larger Kc value refers to the reaction is proceeding in the forward direction. That means more amount or the large amount of products are going to form. Sometimes in the numerical, they may ask, what does the Kc value, indicates? If the Kc value is very high, it indicates that the reaction is proceeding in the forward direction, and so that large amount of products are going to form. Hope you understand that. Let me go for the second numerical. Children, let me take up the second numerical on the equilibrium constant. Calculate the equilibrium constant for the following reaction. The reaction is 4Br minus plus O2 plus 4H plus giving rise to 2Br2 plus 2H2O. Is it not? Now, given E naught cell is equal to 0.16 volts, comment. Children, very simple numerical. Let me solve this numerical. In this case, there is no need to find out which one is undergoing oxidation and reduction in the chemical reaction, because E naught cell is already given. So what I do? I directly put the value of E naught in the expression to find out the log Kc value. Is it not? Let me write. Look at here. E naught cell is equal to minus 0.0591 upon N into log Kc, or log Kc is equal to minus N into E naught cell upon 0.0591. Children, what is N here? N is nothing but number of electrons being transferred here. Look at here, 4Br minus is getting converted into Br2, whereas 4H plus ion is getting converted into 2H2O. That means 4 electrons are involved in the formation of H2O. How? Look at here, 4H plus when takes up 4 electrons lost by 4Br minus, look at here, you are going to see the formation of 2 molecules of water. Is it not? How many electrons are involved here? 4 moles of electron, that is equal to N is equal to 4. Hope you understand that, right? Now, minus 4 into E naught cell is how much here? 0.16 upon 0.0591. Children, we just neglect this negative sign, and if that is the case, you are going to get 10.82. This is what? Log Kc. Now, how do you find out the Kc value? Now, Kc value you can find out by taking the anti-log of this value. So, anti-log of 10.82. Children, by using the anti-log table, you can find out the value, and it is around 6.918 into 10 to the power of 10. So, this is what? Kc value. Look at here, the Kc value is very large. Children, greater the Kc value, always remember the equilibrium will shift toward the forward direction. When the equilibrium shifts toward the forward direction, what will happen? The large amount of products are going to form. That you need to remember. Children, let me take up a next numerical on equilibrium constant. Calculate Kc for the reaction 2Fe3 plus 2I minus giving rise to 2Fe2 plus iodine. Given E naught of cell is equal to 0.235 volts. Children, let me solve this numerical. You know the expression to find out the Kc value. What is that? E naught of cell is equal to minus 0.0591 upon n into log Kc. We are supposed to find out Kcr. That means log Kc is equal to minus n into E naught of cell upon 0.0591. Children, E naught cell value is already given, is it not? That means you are supposed to find out n value here, and that you can find out by using the reaction. Look at here, Fe3 plus is getting converted into Fe2 plus. That means there is decrease in oxidation state from +3 to +2, and decrease in oxidation state is called reduction, is it not? Now other side, I minus is getting converted into I2. That means from -1 oxidation state, it is increasing to 0 oxidation state. That means oxidation takes place. Children, look at here. Let me take up only one. 2I minus is getting converted into I2. Is it not? How many electrons it has to lose? It has to lose 2 electrons. And look at here, Fe3 plus ions is getting converted to Fe2 plus ions by taking 2 moles of electrons. Is it not? Now N is equal to how much? N is equal to 2, because 2 moles of electrons are required for the reduction of 2 Fe3 plus ions to 2 Fe2 plus ion. Remember, if it is only 1 Fe3 plus, there is only 1 electron, but there are 2 Fe3 plus ions. That means 2 moles of electrons are required. Hope you got it, right? Now let me substitute the value here. Log Kc is equal to minus 2 into E naught is equal to how much here? 0.235 volts upon 0.0591. Children, you should neglect this minus sign here. If that is the case, you are going to get 0.47 upon 0.0591. Children, if we simplify, log Kc is equal to 7.95. Now Kc can be found out by taking anti-log of 7.95. Children, we know how to find out the anti-log value. So you find out, you are going to get 8.913 into 10 to the power of 7. So this is what Kc value for you. Hope you got it. Let me take up one more. Look at here. Calculate Kc for the reaction NiO2 plus 2Cl minus plus 4H plus ion giving rise to Cl2 plus Ni2 plus 2H2O. Given E naught cell is equal to 0.320 volts. Children, let me give this for your homework. So how to find out the N here? How to find out the N? Look at here. Nickel NiO2. Look at here. NiO2 is equal to 0. Let it be as X plus 2 into minus 2 is equal to 0. Now X is equal to how much? X is equal to plus 4. So this is the plus 4 oxidation state. Is it not? It is converted into what? It is converted into plus 2. That means there is decrease in oxidation state, or the number, what you call this, it is called reduction. Is it not? Look at here. From this, 2Cl minus is getting converted into Cl2. Elemental form is nothing but having oxidation state is equal to 0. That means minus 1 into 0. Decrease in oxidation state. What do you call this? Oxidation. Is it not? Look at here. In this case, you know, Ni plus 4 is getting converted into Ni plus 2 or 2 plus by losing 2 electrons. Now those 2 electrons are taken, taken by whom? Taken by Cl minus to form Cl2. Is it not? Now N is equal to how much? N is equal to 2 moles of electrons. Now once you know the N, You know the value of E naught cell, you substitute the value, and at the end you have to find out the Kc value. Children, after solving some numericals on equilibrium constant, let me take up the numericals on Gibbs energy change. The standard electrode potential E naught for the Daniell cell is plus 1.1 volts. Calculate delta G naught for the following reaction: Zn plus Cu2 plus giving rise to Zn2 plus Cu. Let me solve the numerical solution. Children, E naught cell is given, that is a plus 1.1 volts, and you know the expression for finding out the Gibbs energy change is equal to minus Nf into E cell. Children, under standard condition of 298 Kelvin, 1 atmospheric pressure and 1 molar concentration, now we can change the expression as delta G naught is equal to minus Nf into E naught cell. Children, E naught cell value is given, is it not? Now we should know the value of N as we know the value of Faraday, that is equal to 96,500 joules. Is it not? Then how to find out N value here? Please look at here. Zn loses 2 electrons to form Zn2 plus. Is it not? Look at the copper. Cu2 plus ions takes up the 2 electrons which are lost by the zinc and get reduced to copper. Children, look at here. For 1 mole of Cu2 plus ion to reduce, you require 2 moles of electrons. That means N is equal to 2. Hope you got it. Now let me substitute the value. Minus N is equal to 2 into Faraday, you know that 96,500 joules, into E naught cell is equal to 1.1. If you simplify, you are going to get minus 212,300 joules per mole, or I can write as minus 212.3 kilojoules per mole. It's a very simple numerical. Just substitute the value and you are going to get the delta G naught value. Children, very important numerical for the examination. Let me take up one more numerical on the same type. Children, let me take up one more numerical on change in Gibbs energy. The zinc silver oxide cell is used in hearing aids and electrical watches. Zinc is getting converted into zinc 2 plus ions and electrons. E naught value is given minus 0.76 volts. Ag2O plus react with water in the presence of electrons to form Ag and OH minus ions. E naught value is given 0.34 volts. Children, 2 parts are there in this question. A, which is oxidized and reduced. B, find E naught cell and delta G naught in joules. It's very simple. Let me solve this numerical for you. Part A, which one is oxidized and reduced? Children, look at here. Zinc loses electrons and forms Zn2 plus ions. Is it not? Now you know that loss of electrons, what do you call this? Oxidation. That means zinc is oxidized. Hope you got it. Is it not? Look at it in this reaction. Ag plus, I take 2 Ag plus, takes up 2 electrons which are lost by the zinc and get reduced to Ag. What is happening here? Children, gain of electrons. Now what do you call the gain of electrons? Is reduction. Is it not? That means Ag plus is reduced. So first part is over. Let me go for the second part. What is that? Finding E naught cell and delta G naught. Let me take up the first one, E naught cell. And you know the expression, E naught cell is equal to E naught cathode minus E naught anode. Now look at here. The electrode where the oxidation takes place is called, what do you call that? Anode. The electrode where the reduction takes place is called cathode, is it not? Now in that case, look at here. E naught Ag plus bar Ag minus E naught Zn2 plus bar Zn. Now the values they are given there. Look at here. E naught Ag plus how much? It is 0.34 volts minus of 0.76 volts. Children, if you simplify, you are going to get 1.1 volts of E naught cell. So second part, E naught cell is over. What is left out? Delta G naught. Children, look at here. Delta G naught is equal to minus NF into E naught cell. Is it not? Now look at here. Number of electrons which are used for the reduction process is equal to 2. That means 2 moles of electrons are used for the reduction of 2Ag plus 2Ag in this reaction. So N is equal to how much? N is equal to 2. Look at here. Let me substitute the value here. Minus 2. Faraday, you know that how much? It is a 96,500 into E naught cell. You got it. How much? It is 1.1 volts. Children, if you simplify, you are going to get minus 212,300 joules per mole. So this is what delta G naught value for the reaction which is taking place in zinc bar silver oxide cell. Children, let me take up one more numerical. The E naught value corresponding to two following reduction electrode processes are as follows. A, Cu plus bar Cu is equal to 0.52 volts. B, Cu2 plus bar Cu plus is equal to 0.16 volts. Formulate the galvanic cell and calculate the cell potential and delta G naught for the cell reaction. Let me solve. Solution. First, I need to formulate galvanic cell. Children, for formulating galvanic cell, you should know anodic and cathodic reaction, is it not? Let me write anode reaction first. Look at here. In this case, Cu plus is getting converted into Cu2 plus 1 electron is lost. Children, look at here. From +1 oxidation state, it is becoming +2 oxidation state. That means increase in oxidation number, which means that oxidation, is it not? Oxidation takes place at anode. Cathode. Children, at cathode, look at here. Cu plus takes up the electron which is lost by the first reaction to get reduced to Cu. Look at here. Reduction takes place. You know that reduction takes place at cathode. Now once you know anodic and cathodic reaction, now I can represent the cell. You know the ABC of the cell. A stands for anode, C stands for cathode, B stands for salt bridge. Is it not? Let me write the anode. You know that anode oxidation takes place. Let me write. Look at here. Cu plus bar Cu2 plus, both aqueous. Is it not? Other side, cathodic reaction takes place. Look at here. How do I write that? Cu plus bar Cu. This is aqueous, this is solid. So this is what the cell representation for a cell involving these two anodic and cathodic reaction. Once this over, let me go for finding the cell potential. E naught cell is equal to E naught cathode minus E naught anode. Children, cathode is what? Cathode is, look at here, E naught Cu plus bar Cu minus E naught Cu2 plus bar Cu plus. Is it not? Now you know the value. E naught C plus bar Cu is equal to 0.52 minus 0.16. Now if you subtract, you are going to get 0.36 volts. This is E naught cell. Is it not? Once you find the E naught cell, now I'll go for the third part, that is delta G naught. Delta G naught is equal to minus NF E naught cell. Now N we need to find out. Is it not? Look at here, children. Now how many electrons are transferred here? Yeah, N is nothing but number of electrons involved in, reduction process. That is, for the reduction process, 1 mole of electrons are involved. That means N is equal to 1. Hope you got it. And F is not what? How much? 96,400 joules per mole. Now let me substitute here. Delta G naught is equal to minus 1 into 96,400 into what the E naught value here? 0.36. Children, if you simplify, you are going to get minus 37740 joules per mole, or you can represent in terms of kilojoules, minus 377.4 kilojoules per mole. So this is how you need to calculate delta G naught as well as E naught cell. Children, let me take up the next numerical for you. The cell in which the following reaction occurs, 2Fe3 plus 2I minus giving rise to 2Fe2 plus I2, has E naught cell is equal to 0.236 volts at 298 Kelvin. Calculate the Gibbs energy change and equilibrium constant for the reaction. Let me solve this numerical for you, children. Solution. Children, before finding out a standard Gibbs energy change and equilibrium constant, let me write anodic and cathodic reaction. And you know that at anode, oxidation takes place, is it not? Whereas at the cathode, you know that the reduction takes place. Look at here. In this reaction, I minus 1 is getting converted into I2. That means from minus 1 oxidation state to 0 oxidation state. That means increase in oxidation number. That is nothing but oxidation. Hope you understand that. Let me write 2I minus is getting converted into I2 by losing 2 electrons. Children, look at here in this case. Fe3 plus is getting converted into Fe2 plus ions. That means from plus 3 oxidation state, it is decreased to plus 2 oxidation state. That means decrease in oxidation state refers to reduction. Children, let me write 2 Fe3 plus taking up 2 electrons which are lost in the first reaction. You are going to get 2 Fe2 plus ions. Remember, N is equal to 2. Why? For the reduction process of 2Fe3 plus 2Fe2 plus, you require 2 moles of electrons. Now, let me take up the first part, that is finding out standard Gibbs energy change. Delta G naught is equal to minus N into F into E naught cell. So N value just now you found out how much? It is 2. And Faraday, you know that 96,500 joules. And E naught is given here, it is 0.236 volts. Children, if you simplify, you are going to get minus 45548 joules. This is delta G naught. Hope you understand that. Now once you found out this delta G naught, then let me go for the second part, that is Kc. Children, you know the expression A naught cell is equal to minus 0.50591 upon n into log Kc. Now you are supposed to find out Kc. Log Kc is equal to minus 0.0591 n into E naught cell. Is it not? Now n is how much here? N is 2. E naught cell is how much here? E naught cell 0.236. 0.236 upon 0.0591. Children, if you simplify, you are going to get 7.986. This is log Kc. Now, how do you get the Kc? Kc value can be obtained by taking anti-log of this. This is equal to 9.683 into 10 to the power of 7. So this is how you need to calculate delta G naught as well as Kc for the reaction in which both oxidation and reduction takes place simultaneously.